Good morning, good afternoon, good evening, whatever the case may be. We are back in better than ever, and today we are talking about real polynomials as we ease into it with the classic rock band ELO Electric Light Orchestra and their absolute monster hit, Turn to Stone. Let's get to it, shall we? All right, real polynomials. We've heard of polynomials. We know what they are: x squared plus 2, 3x. Actually, a constant is a polynomial too. But here's a formal definition. A polynomial function is a function of the form p of x equals a sub n x to the n. And then each of the terms keeps the decreasing by 1, the coefficients, as well as the exponent until you get to a constant a sub n. X is the variable, a sub 0 is the constant term, a sub n is the leading coefficient. That is a big one, that we understand that term. Leading coefficient is always the coefficient that is with the variable with the greatest exponent, which in this notation is always going to be n, because it goes n minus 1, n minus 2, n minus 3, and they go all the way down to x squared, x sub 1, down to the constant. A sub r is the coefficient of x to the r for r equal to 0, 1, 2, and n is the degree of the polynomial. So whatever the greatest exponent is, that's the degree of the polynomial. We are going to talk about summation notation later in the course, even if, well, we might have talked about it already, but we will certainly talk about it if we have not. So we can also express a polynomial using summation notation. All right, so what are we doing with polynomials? I am not going to do this example. Let's see, multiplying polynomials, p of x times q of x. This is a long way, and the reason I'm even making this video is to show you a very nice, quick way to multiply polynomials. But multiplying polynomials is just taking every term in the first polynomial and multiplying it by every term in the second polynomial, and then simplifying. Synthetic multiplication. So let's say we had x cubed plus 2x minus 5 times 2x plus 3. Now we could either take, just like before, we could take every single term times every term in the other polynomial, but we can recreate that using synthetic multiplication. And here's how that is done. We list the coefficients of the first polynomial. 1. Actually, it should always be the longest polynomial. Since this is a trinomial, then we'll list that on first. We'll list those coefficients first. If it's the same, if it's a trinomial times a trinomial, then it doesn't matter. So 1, 0, 2, minus 5. But Mr. Becker, where did the 0 come from? Well, if you look at our exponents, we went from x cubed to x to the first, and what's really there, but we never write, is a 0x squared. So if you have an exponent missing moving downwards, then you must enter a 0 in for it if you are going to use synthetic multiplication. So this is a simpler polynomial. It's 2x plus 3, and we have to line up our coefficients with the correct powers. So it was 2x to the first. This is the first power here. So this 2 right here comes from here, and then the constant is a positive 3. And then we're going to multiply almost like the algorithm for multiplication, except we are not going to do any of that carrying nonsense. So watch this. 3 times negative 5 is negative 15. 3 times 2 is 6. 3 times 0 is 0. 3 times 1 is 3. Okay, but like the multiplication algorithm, I'm moving over one place. So 2 times negative 5 is negative 10. It does not go here. I start one place over, put it right beneath the 6. 2 times 2 is 4. 2 times 0 is 0. 2 times 1 is 2. And now all we're going to do is add these. Negative 15. 6 minus 10 is negative 4. 0 plus 4 is plus 4. 3 plus 0 is 3. And 0 plus 2 is 2. So what do we have here? What we have here is the coefficients of the result. And all we have to do now is put in the variables with their exponents. So we have to think just a tiny bit. If I were to take x cubed times this x, the result would be x to the 4th power. So that is going to be my first term and exponent. And then I just go down the line, 2x to the 4th plus 3x cubed plus 4x squared minus 4x minus 15 is the result. So x cubed plus 2x minus 5, let's fix that plus, times 2x plus 3 is equal to 2x to the 4th plus 3x cubed plus 4x squared minus 4x minus 15. Don't believe me? Do it the long way. So, along with multiplication of polynomials, sometimes we have to divide them. And here is the algorithm. And I'm not going to read it to you, but fortunate enough, there's also synthetic division. And here's how it works. We are taking x cubed minus x squared minus 3x minus 5. And I did this one so you can see that we're going to get the correct answer, which is right here. Okay, so let's see how this works out. Okay, so to do that, there's lots of different notation. I learned it this way, so this is what I always use. In this little box, I'm going to put my divisor. But my divisor is the solution to the denominator. So it's like setting x minus 3 equal to 0 and solving. And so I'm going to put a 3 there. Then I'm going to list the coefficients of the dividend. So the coefficients of x cubed minus x squared minus 3 minus 5 are 1, -1, -3, and -5. I didn't have any exponents missing, so I didn't have to put in a 0. So then I'm going to put a line there, okay? And I am going to bring down this 1. This, whatever's here, you bring down. And then I start multiplying. 3 times 1 is 3. And then I just combine these two. -1 times 3 is 2. 3 times 2 is 6. -3 plus 6 is 3. 3 times 3 is 9 right here. And -5 plus 9 is 4. And I'm not going to go through it, but it's really the same thing that is happening here in this long division. Okay? And now we have the coefficients of our result. But you have to think a little bit, just a little bit. If you're going to take an x cubed and divide it by an x, your result is going to be an x squared. In other words, your first term is going to have to be an x squared. So what we get here is a 1x squared plus 2x plus 3. Okay, so these are the coefficients of the quotient. Well, what about the 4? Well, the remainder is the 4. And if you have a remainder, you always put that over, just like in long division, you put it over the divisor, x minus 3. And that, boys and girls, is our result. Look, it checks out. X squared plus 2x plus 3 plus 4 over x minus 3. Very quickly. So much quicker than going through this mess. Let's try one more. Okay. So this time, our root or our solution to x plus 3 equal to 0 would be -3. So I'm going to start with a -3. Then I'm going to list the coefficients. X to the 4th, the coefficient is 1. There's no x cubed, so I need to put in a 0. Then a 2. There's no x term, so I need to put in another 0, just like they did right here. And then the constant is -1. And then it is very, very quick. Bring down the 1, whatever term is here. 3 times 1 is 3. 0 and 3 is 3. 3 times 3 is 9. 2 plus 9 is 11. 3 times 11 is 33. 0 and 33 is 33. 3 times 33 is 99. -1 and 99 is 98. So the result of this division, again, I'm going to go 1 less than the dividend. As far as the exponent goes, it's going to be, let me extend the page here, 1x to the 4th. Oops, nope, cubed. I broke my rule there. 1x cubed plus 3x squared plus 11x plus 33 plus 98 over the divisor, which was x plus 3. Check our answer that they gave us in the book. Boom. Again, so much quicker than going through all of this horrificness, and so much of a less of a chance of making an error. Okay. Now, the thing about synthetic division is it only works if you're dividing by a linear factor like x plus 3. But if you're dividing by, say, a binomial, you do have to go through the long division process. So let's go ahead and do that. So that would be x squared minus x plus 1, and I guess it has this little thingy if you want to put it there, x to the 4th plus 4x cubed. There's no squared term, so I have to write plus 0x squared minus x plus 1. So we got a ways to go. So what times x squared equals x to the 4th? That's going to be x squared. X squared times x squared is x to the 4th. X squared times negative x is minus x cubed. And x squared times 1 is x squared. So that's a plus there, sorry. And then we're going to subtract all of this. X to the 4th minus x to the 4th is 0. That's what we wanted. 4x cubed minus a negative x cubed is 5x cubed. 0x squared minus x squared is minus x squared. And now we're going to bring down our next term, which is minus x, and start all over again. Oh, this is cubed. Sorry. 5x cubed. All right, so now what times x squared is 5x cubed? Well, that's just going to be a 5x. 5x times x squared is 5x cubed. 5x times negative x is negative 5x squared. 5x times 1 is plus 5x. We are going to subtract all of that. You see how lengthy this is? It's nasty. 5x cubed minus 5x cubed, 0. It better be. Negative x squared minus minus plus 5x squared is 4x squared. Negative x minus 5x is minus 6x plus 1. Okay. Oh, and look what I forgot. I did it again. This is 4x squared. So let's finish this up. I got to extend the page again. What times x squared gives 4x squared? That's going to be a plus 4. So 4 times x squared is 4x squared. 4 times negative x is negative 4x. And 4 times 1 is plus 4. We're almost done, thank goodness. So 4x squared minus 4x squared, 0. Negative 6x minus a negative 4x is a negative 2x. And 1 minus 4 is a negative 3. So the result, finally, of this division is x squared plus 5x plus 4. And we have a remainder, so we have to put it over the divisor. But if there was a 0 here, we would be done if there was no remainder, but there is. So we could say plus negative 2x minus 3 over x squared minus x plus 1. Or if this minus 2x minus 3 is bothering us, we could also write x squared plus 5x plus 4, factor out a negative 1, and write minus 2x plus 3 over x squared minus x plus 1. Oh, how painful. I hope we don't have to do that, but you just might. That is all that I have for you. So we're going to go out with a little bit more ELO, turn to stone. And with that, I am out.